From section 3.1, compound interest and applications, I'll be doing problem number 63. On the day of a child's birth, a parent deposits $30,000 in a trust fund that pays 5% interest compounded continuously. Determine the balance in this account on the child's 25th birthday. So the key word right here is compounded continuously, which gives us the formula A, which is the amount, equals PERT. And the P is what you invest in, the R is the rate, and the T is the time. So first we have to find the rate, which is 5%, which gives us our R. Next we have to find our time, which is the 25th birthday, so 25 years. And lastly, we find the initial amount put in, which is our P, which is 30,000. Once put in a formula, you should get something that looks like this. A equals 30,000 times E, which is a number, not a symbol, to the power of 0.05 times 25. And when you input that in a calculator, you should get 104,710.28724, but you will round that to the nearest hundredth, which will give you 100,004,710.29. So that was it. From section 3.3, which is logarithmic functions, I will be doing problem 81, and I will be combining this whole number under one log. Since they all have log to the power of 8, I will be able to do this. So I think the easiest thing is just to start out by writing log 8, because it's all under one log and it helps it keep it together. And so first I'm going to figure out my key numbers, which is 1/3, which will put everything in this bracket under a radical to the power of 3, and also this plus sign, which will combine these by multiplication, and this 2 right here, which will put this to the power of 2, because we'll move it, and this right here, which after we are done with what's in the brackets, we'll put this in the denominator of this. And so I'm going to start with what's in here and put a radical to the power of 3, and I'm going to combine these two. So I'm going to combine y with y plus 4. I'm going to get y times y plus 4, and I'm going to put the 2 right here over here. And now I'm going to, since I'm done with what's in the brackets, I'm going to work with what's over here. And since it's minus, it's going to be division, and so I'm going to divide by y minus 1, and there you go.
If $1 is invested over a 10-year period, then the balance A, where t represents time in years, is given by A equals 1 plus 75,000ths t, or A equals e to the 7,000ths t, depending on whether the interest is simple interest at 7.5% or continuous compound interest at 7%. Graph each function on the same set of axes, which grows at a greater rate. First, we identify the problems given to us in the equation. So, A equals 1 plus 75,000ths is written down below, as well as the second equation, A equals e to the 7,000ths t, is also written down below, and both are given xy charts, so we can prepare a set of points for the problem. Next, we decide the points we want to plug into each equation, and to accurately represent a change in time, I chose 1 year, 5 years, 10 years, 15 years, and 20 years, and plug them into the t value of each equation. We are left with these numbers here, and are able to put them on a graph here. I start with the brown equation, and start plugging in the points for A equals 1 plus 75,000ths t, and move on to the green one, A equals e to the 700ths t, and we can see that the equation in green has a graph that goes up much higher than the equation in brown, and shows that 7% continuously compounded interest is greater than simple interest at 7.5%.